Alright, welcome to Best Academy TV. In this video, we're gonna focus on calculation on chi-square. There is a particular exam question on chi-square. Okay, all you just have to do to get these questions here, question I, to know how to calculate degree of freedom, to know how to calculate chi-square tab, to know how to calculate chi-square tab. So hit the subscribe button and you can get the full video on calculation on chi-square. Okay, now let's approach this question one by one. All right, now first of all, the first question here is to calculate the degree of freedom. So that the formula for degree of freedom for chi-square is this. Let's just get the formula. Alright, the formula for degree of freedom for chi-square is said to be this. For chi-square, degree of freedom is said to be the rho minus 1 into column minus 1. Please take note. So let's know what the rho is. Rho is the lying part, and in terms of calculating the rho, we don't calculate the total. So the rho here is said to be this part 1 2 only. The rho is said to be this part 1 2. We are not calculating the total. Okay, so so the rho here is said to be the line part is said to be 2. That is, I have this to be 2 minus 1 into the column is said to be the vertical part except the total and except the later part. So this is the later part here. This is not the observe. This is the later part here. I won't involve this guy. I won't involve this guy. I won't involve this guy here. So I will start from the number. So this is 1 2. I won't involve the total. So it's 2. So the column is also 2. So this is going to be 2. This is 2. 2 minus 1 from the formula. So that means the degree of freedom here is said to be 1 times 1. That means it means that this guy 2 minus 1 is 1. 2 minus 1 is 1. So 1 times 1 is going to give us 1. Please take it. So we have calculated for the degree of freedom. Okay, let's look into that is for I. Next is II. Let's look into what we are asked to calculate here on the second question. On the second question here, we're asked to calculate chi-square tab. That is a tabulated chi-square or the critical chi-square. So the chi-square tab here, remember for chi-square tab, can only calculate chi-square tab from the table. Okay, now this is chi-square tab. Okay, now first of all, we say that the formant for chi-square tab is said to be this. The formant for chi-square tab is said to be equal to s square alpha into degree of freedom. So the test of independence here is not given to us. The test of independence or the level of significance is not given to us. So since the alpha here is not given to us here, at this point, what am I going to do? So there's something you have to understand here. There's a secret you have to understand here. Whenever the level of significance is not given to you, you have to know the statement. If the statement is a medical statement or the statement is a social statement. Please listen to me carefully. Whenever the alpha or the percentage part is not given to you, you have to know what the statement is saying about. If the statement is medical statement or a social statement. Now, any statement that is not medical statement should be social statement, and any statement that is not social should be what? Medical. Okay. Now let's look into this here. Now, when it is a medical statement, we say that our level of significance is to be 5%. That's alpha will be 5% for medical statement. While for social statement, our alpha will be 1%. Please listen to me carefully in case there's any mistake here. For medical statements, our alpha is 5%, while for social statement, our alpha is 1%. Please take note. So if you read this particular question here, this is going to be a medical statement. You can see it here, patient and all. So that means our level of significance here, which is the alpha part, will be taken as 5%. Please take note. So if alpha is 5%, I'm going to have something like this coming. We are going to have our chi-square tab to be equal to chi-square 0.05 of 1. So the 1 here is the degree of freedom. Please don't forget. So how do we check this in our table? So to check this here, let's bring up our table here. This is the table for chi-square here. This table here. So we check 1, this is the degree of freedom, just like serial number. Degree of freedom is the same as serial number. Okay, 1 under 0.0, 1 under 0.05. We have this to be 3.841. 3.841. You can see the value here. Okay, so we have calculated for this. So the next thing here is to calculate for chi-square CAC. Okay, so now let's calculate for chi-square CAC. Now so that chi-square CAC here, the formula is said to be chi-square CAC. The formula is said to be sum of observed frequency row and column minus expected row and column all squared over expected row and column. Please take note. So class, we all know that the values here, these values we are seeing here, this and this are said to be observed frequency. So that the values in the contingency table are said to be observed frequency. Okay, this ones here are said to be total here. Okay, so total is not involved. Okay, so each of the observed frequency there is an expected frequency. So this guy will have its own expected frequency. This guy will have its own expected frequency. The same thing with this and the same thing with this here. But before we calculate an expected frequency class, we have to know how to specify the expected frequency in terms of the row and the column. Before we calculate the expected frequency here, we have to know how to specify the expected frequency in terms of the row and the column. Please take note. So each of these here, to specify the expected frequency on this is going to be expected of, to know the number of row, I'm having this E here. This will be row 1. This is row 1. In terms of column is column 1. So this is going to be E of 1 1. Listen to me carefully. The row here is row 1. Where this E here is located is row 1. The column is also column 1. So I will say E of 1 1. Now the expected frequency that will be found here will be E of. Now the row is row 1. Remember, row comes before column. I means row, J means column. So that means this will be row 1, column is 1 2, column 2. I have this to be 2. So I'm not going to temper with this. This is total. Okay, now this is also an observed. That means this will be E of. Now the row is row 2. This will be 2. The column is column 1. This will be E of 2, E of 1, E of 2 1. Now let's specify this one here. From what I have told you guys, this is E of. Let's know where this is located now. Okay, now this is in terms of row will be 1 2, right? That is found at row 2. That is 2. In terms of column is 1 2. In terms of row 2, column 2 also. So I will have that to be E of 2 2. Just calm down, you understand. Okay, now my intention here is for me to, since I have different expected frequencies, is for me to specify the expected frequency at that point. Like for this expected frequency here is found at row 1. It's also found at column 1. Okay, I will say E of 1 1. Okay, now this one here, to locate this expected frequency here, we say E of the row is row 1. I say E of 1. The colon 1 2 is colon 2 is to be E of 1 2. So anywhere I see the J part, you put 2. So in terms of this here, sometimes they will just say find E of 2 2. So you just have to come here and find the E of 2 2. Okay, so we are going to understand more on how to calculate expected frequency. Okay, now let's try to know how to calculate expected frequencies. Now to calculate an expected frequencies here, we say that we have formula. Remember, the word expected means it's not given to us in the table, we are expecting the value. It's not given to us in the table, we are expecting the value. Please take note. Okay, now to calculate for expected frequency here, class, we say that it's going to be E of ij is equal to the row total times the column total over row total, okay, or grand total. So now let's know the row total of, to calculate for E of 1 1. Let's know the row total for 1 1. The row total for 1 1 is E of 1 1 is this for the row total. We will write this to be 29. This is going to be 29 times the column total is said to be 27. This is 27. The overall, remember, to get the overall here, you either plus up this row, this kind, or plus up this total here. Either plus up this total or this total, you get this guy here. Please take note. So the overall total is what? 96. Please take note. So it's now time for us to punch our calculator here. Okay, that is 29 times 27. 29 times 27. Let's get this in here. So our E of 1 1 is going to be E of 1 1 E of 1 1 is here to be 29 times 27. So I have this to be 783 divided by 96. 783 divided by 96. So my answer to this is said to be 8.156. I have to approximate to 4 decimal place. 1 2 3 4 2. Okay, so let's do the same thing here in terms of E of, the next is E of 1 2. So I have to take the total for this, the total of the row, because E of 1 2 is found at this row here, first row. The total of the column, which is this one, 69. Okay, let's do the same thing here. So let me clean this part. Okay, in order to get the full video, which I told you guys about this, on how to state the hypothesis, that is, if the hypothesis is either non-hypothesis or accepted hypothesis or alternative hypothesis or rejected hypothesis, is to hit the subscriber button, and you can get the full video on chi-square and also how to state the hypothesis. Okay, so class, let's calculate the next expected frequency here, that is E of 1 2. So let's get the total of the row of it. Of course, the first row, that is 29. We have this to be 29 times, let's get the column of it here. The column of that E of 1 2 is 69. 69. Overall is 96. So punch your calculator on this. Punch your calculator. So I have this to be 29 times 69. I have this to be 2001 divided by 96. So that's 2001 divided by 96. So my answer will be 20.0 0.8438. So approximating to 4 decimal places for accuracy. Now the next thing here is E of 21. E of 21 is said to be E of 21 is said to be the total of this is E of 21 here. The total of the row is 67, the total of the column is 27. So this is 67 times 27 over 96. So let's get the value here. So this is going to be 67 times 27, that is said to be 1809 divided by 96 is equal to 1809 divided by 96. We have this to be 18.8438. Now E of 22, I guess that is the next one. Okay, let's check the table. E of 22, right? Okay, E of 22, the total row for E of 22 is, the total row is 67, the total column is 69. 67 times 69 divided by 96. Okay, so this is going to be class 67 times 69. We have this to be 4623 divided by 96. So 4623 divided by 96. So I have this to be 156.163 under 4 decimal places. Okay, so the next thing here is to substitute into the formula, that is the formula for chi-square CAC. We all know that the formula for chi-square CAC is this. Okay, let me just clean this board, please. So that means the formula for chi-square CAC is equal to the sum of observed frequency row and column minus expected row and column all squared over expected row and column. Please take notes. So now let's replace. So our chi-square CAC will be equal to, now observe, remember the observe, let me get the first observe there. Let's get the value there. The observe is 4, I think so. Yeah, the first one is 4, that is 4. The expected is minus expected. So each of the observe have expected, which is said to be E of 11 we get. So E of 11 here, E of 11 is said to be 8 points. This is E of 11 here, 8.1562 minus 8.1562. You square this over the expected, which is this one here. So divide by 8.1562. Now plus, now the next observe here is said to be 25, minus the expected for 25, which is said to be E of, the next E of 212, okay, which is 20.8438, 20.8438. That is 20.8438. If square this, divide by 20.8438. Now plus the next one here is said to be 23. The next is 23. Remember, in 23 there's an attached expected frequency there. Okay, in 23, which is the observed frequency, there's an attached expected frequency there. So that means this is said to be into 23 minus, so the expected frequency there is said to be 21, and it's said to be 18.8438. 18.8438. You square it, divide, please don't forget 18.8438 plus, lastly here, said to be 44. So this is said to be 44, which is the observed, minus expected in terms of that 44 is said to be 48.1563. 48.1563. 48.1563 over 48.1563. Okay, square this. So all you have to do here is to punch your calculator. That is this minus this. You square the value, divide by this, you have the answer. This minus this, you square the value, divide by this, you have the answer. This minus this, you square it, divide by the answer. This minus this, square this and divide by the answer. So assuming that the answer here is said to be this. Okay, so if the answer of chi-square, let me just teach you guys how to state hypothesis. So just calculate, maybe chi-square calc is equal to, just punch your calculator and get me the answer. Okay, you can post it on the comment section to check if definitely you got the answer. Okay, now at this point here class, let's know how to state hypothesis. Now stating hypothesis can either be, maybe if the value of chi-square calc is greater than chi-square tab. At this point, this is how to relate these two guys here. This chi-square calc is artificial, this chi-square tab is natural. So if artificial is greater than natural, at that point we say we reject. You reject hypothesis, please take note. But if chi-square tab is greater than chi-square calc, at this point here you accept hypothesis. Why? This is natural, which is the tab, while this is artificial. If natural is greater than artificial, at that point you accept that hypothesis. Okay, now this is the only way you can understand this, how to state hypothesis. So after calculating, if this one here is greater than that tab, you say we reject. Why? If the tab is greater than this one, we say what? We accept hypothesis. So this is how to state hypothesis in terms of chi-square test. Okay, what you just have to do here to get the next video on ANOVA, that is one way ANOVA, is to hit the subscribe button. Okay, let's move into ANOVA. Thank you so much.